Welcome to the presentation on multiplying decimals. Let's get started. So I think you'll find out that multiplying decimals is not a lot more difficult than just multiplying regular numbers. And I'll show you in a problem. So let's say, let me pick some random numbers. Let's say I had 7,518. Actually, let's make that 75.18. Clearly, you can tell I'm doing this on the fly. 75.18 times 0.97. So at first you look at this problem, you're like, oh boy, that's tough. These decimals, I don't even know how to approach it. Well, this is what you do. You ignore the decimals when you start the problem, and you pretend like it's just a regular multiplication problem. And if you ignore the decimals, then it would be, like I said at the beginning, 7,518 on top and 97 on the bottom. And if that doesn't make sense, let me just show you. I'm just going to ignore the decimals and do this like a normal multiplication problem. So normal multiplication, I'd start at the ones place, right here. I'd say 7 times 8. Well, 7 times 8 is 56. Carry the 5. 7 times 1 is 7. Plus the 5 is 12. Put the 2 down here. Carry the 1. 7 times 5 is 35. Plus the 1 is 36. Put the 6 here. Carry the 3. And then 7 times 7 is 49. Plus 2 is 52. So we'll just put 52 here. So just like normal multiplication, we just took the ones place right here, the sevens. It's actually not the ones, but we're ignoring the decimal. So if there were no decimal, this would be the ones place. And we're multiplying it by the top number. 7 times 7,518 is equal to 52,626. Just like regular multiplication, we do the tens place. And once again, this isn't really the tens place, but if you ignore the decimals, it would be. And let's cross all this stuff out since we're not using it. 9 times 8, 72. Carry the 7. 9 times 1 is 9. Plus 7 is 16. Carry the 1. 9 times 5 is 45. This is good practice for me too. I haven't done my multiplication tables in a long time. 9 times 5 is 45. Plus 1 is 46. Carry the 4. 9 times 7 is 63. Plus 4 is 67. Now we add. So you're probably thinking, boy, what do the decimals have to do with this at all? I'm just doing a regular multiplication problem. And I'll show you that actually the decimals only come in right at the very end. So what I do is now I just add like I do a regular level 4 multiplication problem. So I say 6 plus 0 is 6. 2 plus 2 is 4. 6 plus 6 is 12. Carry the 1. 1 plus 2 plus 6 is 9. 5 plus 7 is 12. Carry the 1. 1 plus 6 is 7. Okay. So now here's where the decimals come into place. And I think you're going to be shocked by how straightforward this is. What I do is I go back to the original problem, and now I actually pay attention to the decimals. And I say, how many total numbers are behind the decimal point? Well, there's one number behind the decimal point, 2 numbers behind the decimal point, 3 numbers behind the decimal point, 4 numbers behind the decimal point. 1, 2, 3, 4. So if there are 4 numbers behind the decimal point in the problem I did, then I just count here. 1, 2, 3, 4. The answer will also have 4 numbers behind the decimal point, and that's the answer, 72.9246. Now let me ask you a question. If I had a 0 here, would that count as an extra number behind the decimal point? Well, it only would have been if you actually used the 0 in the multiplication. Maybe that confuses you. What I would recommend, if you have any trailing zeros with a decimal like this, you actually should just ignore those zeros and then do the problem just the way I did it. And remember, that's only for trailing zeros. If this was the bottom number, then that 0 would matter. Because it's not a trailing 0. It actually adds, it's actually part of the number. Let's do a couple more examples, and I think that'll make sense. So let's say I had 5, and I'm going to do a simpler example arithmetically, but I think it'll help you with some principles. If I said 5.10 times 1.09, So there's two things we could do. We could just multiply it the way it is. Actually, let's do it both ways, and I'll show you. You get the same answer whether or not you ignore that 0. So in the first case, let's not ignore the 0. Let's pretend like that 0. Let's use that 0, even though that trailing 0 in the decimal, 5.10 is the same thing as 5.1. But let's use it. 9 times 0 is 0. 9 times 1 is 9. 9 times 5 is 45. Then in the zeros place, you put a 0, and then 0 times everything is 0, right? 0 times 0, 0 times 1, 0 times 5. Put 2 zeros here. And then 1 times 0 is 0. 1 times 1 is 1. And 1 times 5 is 5. And now we add it all. You get 0, 9, 5, 5, 5. And like we did before, we just count the decimals. 1, 2, 3, 4. It's 1, 2, 3, 4. So the decimal will go here. Right? So we got 5.5590 as the answer. Now what if we did like I was recommending, we actually ignore the 0. So I say, and I can actually rewrite it as 1.09 times 5.1. Because you know in multiplication, order doesn't matter. A times B is the same thing as B times A. 2 times 3 is the same thing as 3 times 2. So 1.09 times 5.1 is the same thing as 5.1 times 1.09. So let's just multiply this out. And notice, these are the same numbers. All I did is I took this 0 off. So first, I just ignore the decimals. I say 1 times 9 is 9. 1 times 0 is 0. 1 times 1 is 1. Put a 0 here. 5 times 9 is 45. Carry the 4. 5 times 0 is 0 plus 4 is 4. 5 times 1 is 5. Now I add 9, 5, 5, 5. And I say, okay, how many? Now I'm at the point that I can actually pay attention to the decimal points. I say, how many numbers are behind the decimals? Well, there's 1, 2, 3. So I go 1, 2, 3, put the decimal point right here. Notice I got the same exact answer. The only difference is that this one had a trailing 0, which really doesn't make a number any different. I could add 100 zeros here, and the number is really not a different number. This is just, well, if you were a computer programmer, I guess this could become or a statistician of some kind. This could be an important number, but ignore what I just said. And for your purposes, these trailing zeros mean nothing, right? Same way a leading 0 actually would mean nothing. No one ever does that. Let me see how much time I have. I have 2 more minutes. Let me do one more problem just to maybe hit the point home. But really, I just want to, this is really no different than level 4 multiplication, and at the end you just have to count the numbers behind the decimal point. So 5 times 5 is 25. Whoops. It's 25. I'm already getting it messy. Carry the 2. 5 times 7 is 35 plus 2 is 37. Bring down the 7, carry the 3. 5 times 0 is 0 plus 3. So it's 375. Ignore that blob. I'm sorry for being so messy. So then you put a 0. 1 times 5 is 5. 1 times 7 is 7. You can ignore that. And now we add. We say 5 plus 0 is 5. 7 plus 5 is 12. 1 plus 3 plus 7 is 11. So we got our answer. Now we just have to count the decimals. So here we have 1, 2, 3, 4, 5 numbers behind the decimal point. But in our answer, we only have 4 digits. So how can we get 5 numbers behind the decimal point? Well, we start here. We say 1, 2, 3, 4. And we need one more number behind the decimal point. So we add a 0 here. And then we put the decimal point. See what I just did? We had to have 5 numbers behind the decimal point. So we only had 4 numbers in the answer. So I added a leading 0 and then put the decimal point, and now we have 5 numbers behind the decimal point. And I've shown you a very mechanical way of doing this. Hopefully in the future I can give you a seminar on actually why this method of counting the numbers behind the decimal points actually works. But I think you are ready to try some problems, the multiplying decimals. Have fun.